Well, this is part 2 of section 0.2. Today we're going to talk about ordering real numbers. 2.1. Ordering fractions. One way to directly compare two fractions is to rewrite them with a common denominator. However, there are other strategies we can use to compare fractions when we don't want to rewrite them. Strategy 1. Comparing to 1/2 or 1. If one number is greater than 1/2 and the other is less than 1/2, then the comparison is clear. If one number is greater than 1 and the other is less than 1, then the comparison is also clear. So which one is greater? 9/14 or 3/10? Well, half of 14 is 7, so 7/14 would be 1/2. So 9/14 is bigger than a half. And then half of 10 is 5, so 5/10 would be a half. So that means 3/10 is smaller than a half. So which number is greater? Well, 9/14. 14/5 or 7/9? Since 14 is bigger than 5, 14/5 is bigger than 1. Since 7 is less than 9, 7/9 is less than 1. So the 14/5 is bigger. Strategy 2. Same denominator or same numerator. Which would you rather have? 2/7 of a pie or 5/7 of the same pie? Why? Well, here I'm assuming we would prefer the 5/7. So if you have the same denominator, then the larger numerator gives you the bigger fraction. So using this idea, determine which number is greater. 3/7 or 6/7? 6/7. 187 over 503 or 19 over 503? 187 over 503. Then is 17 over 39 or 16 over 39 larger? Well, 17 is larger than 16, so 17 over 39 is larger. Now we've talked about what to do if two fractions have the same denominator. What do you do when they have the same numerator? So would you rather have 1/3 of a pie or 1/5 of a pie? Why? I personally would prefer 1/3 because if you split it into 3 pieces, the pieces are bigger than if you split it into 5 pieces. So the big idea here is if you have the same numerator, then the smaller denominator gives you the bigger fraction. So in example 5, determine which number is greater. Well, the numerators are matched, so the smaller denominator will give a bigger fraction, so 1/4. be 4/9 or 4/11. Since 4/9 has the smaller denominator, 4/9. 3/32 or 3/25. Again, since the 25 smaller denominator, 3/25. Now, there is another possibility when dealing with fractions, and that's to have equivalent fractions. Fractions that look different but are actually equal are called equivalent fractions. Algebraically, we say that two fractions are equivalent if we can get from one to the other by multiplying the numerator and denominator by the same number. So example 6, algebraically determine which sets of fractions are equivalent. Right now would be a good idea to try to pause the video and try to do this on your own. I'm hoping you paused it and were able to figure out most of them. So I'm just going to start left to right, find a fraction that is equivalent to 4/10. Well, 4/10 and 2/5 are equivalent because if we multiply 2/5 by 2/2, that's what will give us 4/10. 2/3. Now 2/3 is equivalent to 10/15, because if we multiply by 5/5, we'll get the 10/15. 6/15, is that equivalent to any? Well, that's actually equivalent to the 2/5. So let me erase that green and go back to the purple. And again, it's because you can multiply the 2/5 by 3/3. So because 4/10 and 6/15 are both equal to 2/5, that also means 4/10 is equal to 6/15. You can either start with 6/15, divide both by 3 to get to the 2/5, and then multiply by 2 to get the 4/10. Okay. 1/2. Hoping you notice none of them were equivalent to 1/2. 1/2 is by itself. 3/5. Well, that's equivalent to 12/20. And you get that by multiplying by 4/4. Okay, good. 66/99. Well, that is the same as the 2/3. Because you can multiply by 33/33. So again, because 66/99 is equivalent to 2/3 and 10/15 is equivalent to 2/3, 10/15 is equivalent to 66/99. And last but not least, we have 6/10. Well, 6/10 is equivalent to 12/20 because you can multiply by 2/2, which means it's also equivalent to 3/5 and so on and so forth. Two 2.2, ordering decimals. Recall, decimals are numbers that belong to the tenths family. Tenths, hundredths, thousandths, etc. that are written in a decimal place value system. So the one on the left is for whole numbers. You have one, tens, hundreds, thousands, 10,000, so on. For decimals, you have tenths, hundredths, thousandths, and so on. Example 7. Write the following decimals in words using proper decimal place system terminology. So 0.34. So the 4 is in the hundredths place. So now you read the number as if there is no decimals, so that would be 34. And since the last decimal place was in the hundredths, this would be 34 hundredths. 4.9. Well, 4 is just 4. Then you use the word and to indicate a decimal point. And then 9 is in the tenth spot, so in 9 tenths. 0.0413. So again, I'm going to write it as if there is no decimal, so 413. And then the 3 is in the 10,000th position, so this is 413 10,000th. And that's how you write a decimal in words. Some things to notice. Adding zeros at the end of a decimal does not change the number. For example, 0.123 is equal to 0.123000. There is a typo in the notes here. There should not be that extra zero right there. The number of places after the decimal point is equivalent to the number of zeros in the denominator when you rewrite the number as a fraction. For example, 0.0413 is equal to 413 over 10,000. How to compare decimals. Starting at the decimal point, read from left to right until one number's place value is larger than the others. Determine which decimal is greater. 0.5, 0.5, 0.58, 0.59. 9 is bigger than 8, so 0.597 is the larger. 0.7, 0.7, 0.71, 0.72. Since the 2 is larger than 1, 0.721 is the larger. 0.09, 0.9. Oh, 9 is larger than 0, so 0.9871 is larger. And then for D, you have to go all the way to the 4th decimal place before they're different. So 0.3201 is bigger because 1 is bigger than 0. That is it for section 0.2.